Analyzing Glass Fractures by Sydney and Jaden. Cracks will form until they run out of energy or material to break. First, it's important to label each fracture.
After you label the inside of the window, you must label the outside of the window. You can do this based on a mirroring technique. If you look at the inside of the window, you can start to see a pattern developing between the two. For instance, since this one is closer to this one, based on the mirroring, this one would be B as well as that one. And since this one's furthest outside, this one would be D as well. Then you need to figure out the side of entrance based on the size of the fractures. You can tell by mirroring the fractures and looking at their sizes the side of entrance. Since the inside of the window fracture is smaller, you can tell that it came from that side of the glass.
Here's how we know that the smaller side is the side of entrance. If an object is flying at the glass, this is what the fracture would look like slowed down. First, the glass would bend or curve against the object. Then the glass would eventually give, fracturing in a concentric pattern. Since the smaller side is the side of entrance, we know that A and B came from the inside, while C and D came from the outside of the window.
Next, you begin labeling which lines go to which fractures based on their point of origin. You do this to each fracture in a different colored marker so that you can keep track of which lines go to which fracture so that you can differentiate the order in which they came in. Be careful when you're color coding the lines because you want to be sure that the line that you are coloring comes from the place of origin that you are stating. For instance, we know that these lines are coming from B because cracks never stem backwards. So since they're actually touching the middle fracture from B, you can tell that that is 100% where it came from. But if you don't know where a crack originated from, don't color it until the very end, or else it could skew your data. The further along you get with color coding, the more evident it becomes the order that the bullet holes came in. Now that you have finished outlining all the lines from the inside of the window, now you move on to the outside of the window. You do this to make sure that the order that you have gotten is correct. It's important to label them the same colors from both sides. For instance, since I did B red on the inside of the window, I'm also going to color all the lines from B on the outside of the window red as well. Same with A, C, and D. This is so that we don't get what lines go to which holes messed up, because that could skew our data and it could potentially give us a false order in which the bullets came in. Keep in mind while you are tracing the mirroring side that the lines will not look exactly the same as they did from the inside of the window. For instance, some lines may be longer or veer off in certain directions, while their mirroring components do not. This does not mean that they are not the same line, but just that they might have slight differences that may make them appear a little bit different. However, they still do belong to the same fracture. After you have finished color coding both sides of the window, you can begin circling all the points of interaction between fractures. This also helps identify the point in which they meet, which helps identify the order in which they came in. Now that you have circled all the points of interaction from the inside of the window, you can move on to the outside of the window. Again, you do this just to be sure that the order that you have gotten from the inside of the window is correct, and that all your data matches. Now you begin to analyze all the lines and the colors, along with the points of interaction. If you look closely, this will help you in identifying the order in which they all came in, so that you can figure out what really happened during the crime.
Once you identify the points of interaction, you should number them. This will be important later on when you're making your proof. You have to number the points of interaction on both sides of the window. Just keep in mind that sometimes both sides won't be identical. Now see if you can figure out what order these fractures came in. Feel free to pause the video if you need more time. Does the order you got match up on both sides of the window? If not, see if any other orders would make sense. Again, pause the video if you need more time. Think you got it? Well, the order is D, C, B, A. Again, that's D came first, then C, then B, and finally A. Now you need to make a proof, so you set up a 3-column chart with order, side of entrance, and proof. Under order, you will list the order in which the glass fractures occurred. Here we have D, C, B, A. Then you will fill out the side of entrance based on the size of the fracture. As we mentioned before, D and C came from the outside, while B and A both came from the inside of the window. We know that because the hole will always be bigger on the side opposite of the impact. When you make your proof, you will follow the format at point blank, radial crack from fracture blank runs into fracture blank. Your first proof will usually start something like fracture D forms until it runs out of energy, because of course the first fracture doesn't run into anything. From there you just follow the format. At points 1 and 2, radial cracks from fracture C run into fracture D. You are taking the points of interaction that you had previously numbered and using them to prove the order the glass fractures occurred in. I proved fracture B came after fracture C by saying that at points 4 and 7, radial cracks from fracture B run into fracture C. The last proof says that at points 4 and 5, fracture A runs into fracture C. And there is your finished proof chart. Analyzing glass fractures can be important in cases such as a hit and run, forced entry, shootouts, or any crime where glass is present. This is the story of a real case that took place on June 3rd. A woman by the name of Anvitha was returning home on a motorcycle that night when a speeding vehicle knocked her down. The woman suffered severe head injuries, and she later died at the hospital. At the crime scene, a piece of fiberglass was found. When analyzed, it was found to be part of the fitment below the headlight of Tavera vehicles. Police obtained details of all Tavera vehicles in the area and physically checked each one of them. Eventually, one of the teams found that the piece matched with the missing part of a vehicle belonging to a travel agency. Analysis revealed that the piece belonged to the vehicle. The owner, 34-year-old Santosh Kumar, was booked under hit and run.